What's up, Regents peeps? Yep, it's a little bit freaky here, but yeah, I'm not here. Obviously, this is what you're gonna do today. I wanted to be able to talk you through a little bit of the first part. So this this YouTube, this video way or method is a pretty good way to do that. So, excuse me. What we're trying to do here is what I call a graph translation. I call this graph translation, which means we need to be able to go between a position versus time and a velocity versus time graph. We want to be able to show the same motion on two different graphs. All right, this activity, I will tell you what, is maybe the hardest thing you'll do all year. So for me to not be here, not the best, but I'm sort of here, right? I'm talking to you. Yeah. Okay, so you have in front of you a packet with 4 different scenarios on it. This is the first one. All right, so we should all be looking at the front of that page right now, or the front of that packet right now. And we're talking about 4 different scenarios where we have a cart. This is supposed to be that, like one of those red plastic carts on a track. And remember this thing? It was green before. It's called a motion detector. Remember that? We were walking in front of it back and forth with that big board, and the sound would bounce off it. It would make that graph for us of position and time. We do that graph matching exercise. So that's what that thing is. That's our detector here. Detector. All right. So what we want to do is say, and for each one of these situations, if we do what the situation describes, what's the position in time graph going to look like? What's the velocity in time graph going to look like? Okay. And to help you out, what I did was add these little sort of prompts here. All right. Talks about what's happening in the beginning, what's happening at the end. All right. And that's going to help us ideally draw the graphs correctly. Okay. So, sorry. Yeah, one thing that I made sure to do here was do a little directional definition. So anything that moves away from the detector, we say that's moving in the positive direction. Notice, I'm not saying that downhill is the positive direction. What I am saying is away from the detector is the positive direction. Okay? All right, so let's just start. We'll start right here, right at the beginning. What can you tell me about the position? Where is this thing located? And again, origin really means at the detector. Origin is 0 meters away from the detector. So in the beginning, with the cart sitting right in front of the detector, I would say the position is at position is at, or close to, I don't know, at, something like that. Yeah, let's just say at the origin, right? So that means we know that we start our graph here at position 0, right? Now, what can we say about velocity? Well, at the beginning, if this thing is released, what's the velocity? Well, the velocity is 0. And forget about that. Okay? All right, so the question is, how do I show those things? Well, we know that at the beginning the position is at 0, so we know where to start this graph. And then the question is, how do we show in the beginning that it has 0 velocity? Right? Now, maybe we'll come back to that. Okay, now, at the end, the position is, well, I'm going to say, I don't know, away from the origin. Right? It moves away from the origin. Sure. Right? This thing, when we release it, come on. When we release it, yeah, it's going to go down the hill like that. Okay? And okay, at the end, and this isn't the end is right now, just before it stops. At the end, the velocity is what? Well, it's big, and it's positive, because again, it's moving away from the detector. Okay? So, let's see. A couple things we need to be able to do. Now, maybe if we take position stuff at first, well, we're going to say at the beginning, it starts here at the origin. At the end, it's away from the origin. Okay? Now the question is, how do we connect those? Well, if we go with velocity over here, and the beginning velocity is 0. Well, here's 0 velocity. At the end, the velocity is big and positive. Well, here's big positive. All right? All right. Well, what I know is we never, ever have curves on velocity and time graphs. So this one, all we have to do is this, right? There's our object that speeds up, right? Positive velocities, positive accelerations. Remember that from yesterday? Yeah. Now, over here on the position in time, how do we get from this to this? Well, it's not a straight line because this thing is not moving at a constant speed. Okay? It's a curve. And the question is, I mean, there's one way to do it like this. There's another way to do it like this. Which one is it? Well, remember, we have to make sure the velocity that we can tell from this, that the velocity matches up to what we need. Right? In the beginning, velocity is 0. Well, how do we show that over here? That means that slope is 0. Right? In the end, velocity is big and positive. That means that slope is big and positive. Right? So that means that it looks like this. Slope starts at 0. Slope gets big and positive. What do you think about that? So, what I need you to do, and you have the rest of the class to do this, and you should work, everyone should finish their own or do their own, but I would really encourage you to work in a group of no more than 3. All right, 2 is good, 3 is good, 4 too many. 4 means someone's sitting there just writing stuff down that other people are writing down. So find a group of, 2 or 3, all right, and try to walk through these next 3 examples. Okay. This is going to be challenging. Like I said, this is one of the literally the hardest, the most, it's pretty abstract, right? There's not a lot of numbers. This graph translation stuff is really tricky. But I think hopefully with these sorts of things here and here to try to guide you through it, you should be okay. All right, folks? We'll certainly go over it on Monday. Again, you have no homework. I got to change this and start giving you homework. But enjoy homecoming. Enjoy the dance if you're going. Enjoy the game if you're going. Stay out of trouble. Make good decisions, okay? See you.